Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss all about de-Broglie hypothesis. Let's begin. De-Broglie, one of the scientists who proposed a hypothesis. So, what is hypothesis? When you are performing a research on a particular topic, you have to propose an idea, and later on, when that idea was confirmed by an experiment, till that proposed idea is considered as hypothesis. When de-Broglie was one of the research scholar and he completed his Ph.D. and he wrote his thesis. In his thesis, he showed that hypothesis. According to de-Broglie, a wave is associated with every moving material particle. And these waves are called de-Broglie waves or matter waves. De-Broglie waves or matter waves. De-Broglie. Before de-Broglie, it is considered that radiation has particle as well as wave in nature. There are so many experiments which confirm the wave nature of radiation. Some of the experiment are Young's double slit experiment, which confirm the interference pattern. Some of the phenomena in light as diffraction, polarization, which confirm the wave property of radiation. Again, another experiments like Einstein's photoelectric effect, Compton effect, which show the particle nature of radiation. According to de-Broglie, nature loves symmetry, and all the universe is made up of matter and radiation. Since radiation has dual nature, particle as well as wave, so matter should have dual nature, as matter is particle, but it must be show wave character. By taking that assumption, he showcased his hypothesis as each and every moving material particle, let we choose that is a particle, So a wave is associated with this particle, that is a wave, and that wave is called de-Broglie wave or matter wave, which is called de-Broglie wave or matter wave. That wave is called matter wave. A wave is associated with every moving material particle, and these waves are called de-Broglie waves or matter waves. That was the hypothesis of de-Broglie. Since it is a wave, so it has wavelength. Since it is a wave, so it has wavelength, and the value is given by the wavelength of such matter wave as lambda is equal to Planck's constant divided by momentum. Whereas H stands for Planck's constant, lambda stands for wavelength of de-Broglie wave, or matter wave. P stands for momentum of the particle. We can derive that equation derivation. According to quantum theory, energy of a photon which is quantized, that is equal to h nu. According to quantum theory, E is equal to h nu, whereas nu is the frequency. Equation number 1, nu, that is the frequency of radiation. Since we consider this is the energy of photon, E stands for energy of a photon, and the velocity of a photon is equal to the velocity of light, means it is comparable with the speed of light. So we can use the relativistic condition. The relativistic energy of a particle, relativistic energy of a particle is equal to m naught square c square, m naught, that is the rest mass, plus p square c square under root. Equation number 2, whereas m naught be the rest mass, p as usual momentum, c velocity of light, as we use that equation for photon, since rest mass of photon is 0, therefore E is equal to p square c square under root, as rest mass of photon m naught is equal to 0. The energy expression is equal to P into C. Again E is equal to h nu. H nu is equal to P into C, or momentum P is equal to h nu by c, h nu by c. From that of wave, so the velocity is equal to distance lambda divided by time period t, 1 by t, that is the frequency, or c is equal to frequency into wavelength. Instead of c we use that relation, or p is equal to h nu divided by nu into lambda. Nu cancel out, so p is equal to, that is nu by nu cancelled out, h by lambda. Therefore lambda is equal to h by p. Lambda is equal to h by p, which is the equation for photons. Equation for photon. If we use that equation for any particle having mass m and velocity v, that particle moving with velocity v, then wavelength lambda is equal to h divided by mv. Since photon is the particle, this is the expression for de-Broglie wavelength. By taking that hypothesis, he showcases the expression for its wavelength. From that experiment, from that of expression, mathematical expression, look that expression. The wave associated with a moving particle is independent of charge of such particle. There will be no term relating to that of charge. Means the de-Broglie waves can't be electromagnetic in nature. This is a wave which is not electromagnetic in nature. Since we consider the production of electromagnetic wave, there is the requirement of a charge. No charge is there. It depends upon mass and velocity. If mass less, wavelength increased. The lighter the particle, greater be the de-Broglie wavelength. Again velocity. If that particle travels faster, then that de-Broglie wavelength will be small. The de-Broglie wavelength is independent of charge of the particle, and that de-Broglie wave, which is called matter wave, is not electromagnetic in nature. This is all about the hypothesis proposed by de-Broglie. A wave is associated with every moving material particle. A wave is associated with every moving material particle, and that type of wave is called de-Broglie wave or matter wave, and the wavelength of such de-Broglie wave lambda is equal to h by p. Next, velocity of such a de-Broglie wave. This is the moving particle, and the wave associated with that of moving particle is a matter wave. Let we consider that a particle having mass m that move with a velocity v, and the velocity of a matter wave is v of p. Then how it relates to this? Velocity of de-Broglie wave. According to de-Broglie, if a particle having mass m is moving with a velocity v, then the de-Broglie wavelength is given by lambda is equal to h divided by momentum, mass into velocity. That equation number 1. From quantum theory, known that the energy of particle, according to quantum theory, energy of particle which is quantized is equal to h nu. Nu be the frequency associated with that particle, as you know it. Therefore, nu is equal to E by h. Again, according to Einstein's mass energy relation, equation number 2, according to Einstein's mass energy relation is equal to mc square. C be the velocity of light, whereas this is equation number 3, let, and we put that value in that equation number 2. Therefore, equation 2 becomes nu is equal to mc square divided by h. mc square divided by h. Prefer it as equation number 4. As we know that velocity of light c is equal to frequency into wavelength. If we choose v of p is the velocity of de-Broglie wave, then that velocity v of p is given as its frequency and wavelength. and the values of frequency and wavelength we put here. So that velocity of de-Broglie wave is equal to, in place of nu, mc square divided by h, in place of lambda, that is h by mv, h by mv, h cancel out, 1m cancel out. So the velocity of that de-Broglie wave is equal to c square divided by v. Look that equation. This is the velocity of particle v. V, that is the velocity of particle. Velocity of particle be less than the velocity of light. Be less than the velocity of light. Why? As you know, v is less than the velocity of light. No particle move faster than that the speed of light. Hence, in that of expression, v of p, which one is the velocity of the de-Broglie wave, is greater than c. What clarify that equation? De-Broglie wave move faster than the velocity of light. De-Broglie wave travel faster than the velocity of light. De-Broglie wave travel faster than the velocity of light. Again, which contradicts that hypothesis proposed him. Wave is associated with every moving material particle, but if that wave, the speed of wave is greater than that speed of particle, then how it is possible? Means particle is there and that wave move faster. Exactly that doesn't happen. But later on it is confirmed by Davinson and Germer experiment that matter show the wave characteristic property. So how it is possible? It is contradicts the hypothesis proposed by de-Broglie. But after that, Schrödinger, another scientist, came into picture and he modified it as there is not a single wave associated with that moving particle. There are a group of waves which is called wave packet, and again he formulate mathematically it. We can show it in upcoming videos. Next, wave particle duality, which is complementary. According to complementary principle, the wave and particle aspects of matter are complementary rather than contradictory. The wave and particle aspects of matter are complementary rather than contradictory. Means both aspects are necessary to complete the picture of a system. And that was experimentally proved. There are so many experiments which confirm the matter have wave as well as particle characteristic, and these two characteristics are complementary with each other. One of such experiment is Davinson-Germer experiment. In that of experiment that show matter is not only particle but also wave. These two aspects are shown by Davinson and Germer experiment. In upcoming video, we discuss about what is Davinson-Germer experiment, which confirm the de-Broglie hypothesis. So here, with the help of this video lecture, we understand the concept of de-Broglie hypothesis. derivation of that expression lambda is equal to s by mv. Velocity of de-Broglie wave, which conclude that de-Broglie wave move faster than that of velocity of light, means it again show that the particle velocity is less than that of velocity of such de-Broglie wave, which contradictory to its hypothesis. Later on it was corrected by taking another assumption. Next, wave particle duality complementarity, means the dual characteristics of matter as particle as well as wave both are complementary with each other rather than contradictory. These two aspects are useful to us to understand the whole picture of a system. And Davinson-Turner experiment which confirmed de-Broglie hypothesis. So, with this useful and informative notes, let me wind up the session. Thank you.